All right, so we're going to talk a little bit today about proofs. We have talked about proofs a little in the past, but we're going to kind of use them again, but we're going to use them for triangles. So we're going to use proofs, talk about a little bit of logic, and then review some things that we've already learned about congruent figures. So first, about the proof. A proof is a logical argument that shows a hypothesis is true. There are several formats of a proof. A two-column proof, and this is the one that we're going to see and use the most. It has numbered statements and corresponding reasons. So remember, we were practicing the reasons on the algebraic problems where you saw on the left side was the algebra, on the right side you had to write your reasons. Well, now we're going to apply that more to geometry. Theorems are the reasons we used in a proof. So theorems and postulates and just kind of any of the properties we've talked about. Now, a lot of times, remember, we always kind of leave off that end word about this is a postulate or this is a theorem. So just don't think those are new words. We just usually, when we are speaking of them, we usually don't say that part. So theorems are basically all the properties that we've talked about. Like something like supplementary angles, their sum is 180. Well, that is actually called the supplementary angle theorem. Okay, they include definitions. So like the definition of a midpoint, properties, postulates, and theorems. A theorem is different from a postulate in that a theorem can be like proven scientifically or mathematically. A postulate is more of like an educated guess. All right, so let's look at some of these theorems that we're going to be using. So you don't need to know here that it's Theorem 2.1 or Theorem 2.2. What you need to focus on here is the reflexive, symmetric, and transitive. So reflexive is kind of like, think about your reflection in a mirror. So for any segment AB is going to be equal to AB. So like when you look at yourself in the mirror, it is the same exact person. There's nothing different about you. So if you're talking about the reflexive property, you can say that AB is equal to AB. Symmetric property is think about when you like fold something in half, then it is symmetrical on one side and the other. So what happens in the symmetric property is you can switch the order of things. So if you have AB is congruent to CD, then it is also valid to say that CD is congruent to AB. Again, a lot of this is going to seem like common sense. It's stuff you probably already know, you already do, but now we're just kind of putting a new vocabulary word behind it. Remember at the very beginning of the year, I told you this class is about vocabulary. So here's another kind of example of that. Now the transitive property. This is if AB is congruent to CD and CD is congruent to EF, then the first thing is congruent to the last thing. So this should look kind of similar to some things we just got done doing. Remember, we were just doing logic and the law of syllogism where the first thing always led to the last thing. That's what this is. When we use it with geometric properties, we call it actually transitive instead of the law of syllogism. There is one thing I've come up with to try to memorize or keep all of these properties straight is RST 1, 2, 3. And again, this is just a little tool. There's really not any, math, reasoning behind it. It's just something that, someone came up with. Now, the R goes with the 1. And if you'll look at the reflexive property here, it only has one segment in it. All right, or sometimes down here we're going to talk about an angle. So it's just talking about one piece of something. So reflexive 1, RST 1, 2, 3, symmetric 2. So you see when you use the symmetric property, you have to be talking about two different pieces. Transitive property, so RST 1, 2, 3. The transitive property, you see we're talking about 3 different pieces. We have A, B, C, D, and E, F. So again, you can use this to help you remember which one of these properties it's going to be. All right, so for segments, we can also do the same thing for angles. So for any angle A is going to be congruent to angle A. Symmetric, if angle A is congruent to B, then you can flip it around. And in transitive, the first thing always leads to the last. If angle A is congruent to B and B is congruent to C, then A is also going to be congruent to C. All right, so let's see if we can take these and then apply them to a problem. So here's the first example. 4 steps of a proof are shown. Give the reasons for the last 2 steps. So given is that AC is equal to AB plus AB. So they're right here, okay? They're giving you this statement. So remember in a proof, this is a 2-column proof, statements and reasons. The first statement is always what is given. So you rewrite what is given and the reason is given. Next, we're going to say, okay, well, AB plus BC is going to equal to the whole thing. And we have talked about that before, where the 2 pieces add up to the whole thing. So that's segment addition postulate. Now what has happened is they're saying, okay, well, AB plus AB is equal to AB plus BC. So what has happened here is actually the transitive property. All right, now let me show you. Right in here, see how AC is equal to AB? And then AB is equal to AC? And then you have AB is equal to AB plus BC. So basically, again, it was just kind of like a little chain reaction where we have this piece is congruent to AC, these 2 pieces, and we have these 2 pieces that are also congruent to AC. So now we can say that these pieces themselves are congruent or equal to each other, and that's transitive property because you see we're talking about 3 different pieces, AC, AB, and BC. Now what has happened is they've solved the equation. And you can see here, you have an AB on each side of the equation. So you can subtract AB from each side, and you can get AB is equal to BC. And the reason is for the subtraction property of equality. So remember, you'll get kind of used to the reasons here. A lot of the reasons are very repetitive. So don't freak out, okay? You will kind of get used to this, realizing what they're asking for and the reasons. All right, in example 2, we're going to name the property shown. So here it wants to know if it's reflexive, symmetric, or transitive. So we have in A, angle R is congruent to T, angle T is congruent to P, so then R is to P. So 1, 2, 3, so this is transitive, where the first thing is congruent to the last. Then we have NK is congruent to BD, and BD is congruent to NK. So basically, they just flipped the order. So that is symmetric. It's the same on one side as the other. Now, this is all going to be review. We have congruent figures. All right, they are figures with the same size and the same shape. All right, and then inside of the congruent figures, we have corresponding parts. So remember when they say that they're corresponding, it means that they're kind of in the same position. So it's all the angles, and all the sides of congruent figures. So if we look at example 1, we're going to identify the congruent parts. So write a congruent statement for all the triangles. Identify all the pairs of congruent corresponding parts. So in the diagram, The diagram indicates that triangle ABC is congruent to. Now remember when we talked about congruent things, this is where the order matters. So they started off with angle A. So you can see here, it kind of helps if you turn things the same direction, because then you can see, okay, that A corresponds to F. So your next statement when you name that triangle has to start with F, because A aligns with F. So then they went over here to B, which you can see aligns to G. So this is going to be triangle FGH. So make sure the order is exactly the same. So like we just said here, corresponding angles. A is going to correspond to F, B corresponds to G, and C corresponds to H. And again, you can also see that in the markings, because A and F are the 90s, B and G have one arc, C and H have two arcs. Corresponding sides. So side AB you see here has two tick marks, so that's going to be corresponding to FG. BC is to GH. And CA is to HF. Now remember, inside of here, these letters can be switched around. That is okay, because a segment is the same length from the front to the back. Just make sure, and when you're saying, remember this is the congruency statement. That's what this is called, a congruency statement. It has to be in the correct order. So now we can also apply that reflexive, symmetric, and transitive properties to basically a lot of shapes and different things. So now triangles. So for any triangle, triangle ABC is going to be congruent to triangle ABC with the reflexive property. Remember again, reflexive is just one thing, one piece, one figure, angle, side, whatever you have is always going to be congruent to the exact same thing itself. In the mirror, you're congruent to yourself. Symmetric is where it's symmetrical on one side and the other. So you have two pieces. You have one side and another side. So triangle ABC is congruent to triangle DEF. Then you can say triangle DEF is congruent to triangle ABC. And again, like I told you, it probably makes sense. It's common sense, but we're just putting new vocabulary words behind it. Transitive. Triangle ABC is congruent to triangle DEF. Triangle DEF is congruent to triangle JKL. In transitive, the first thing is always going to be congruent to the last as long as it has the similarity there. So the final statement is triangle ABC is congruent to JKL. All right, so if you're listening, I would like you to draw me a little picture of yourself over here on the right. So draw a little stick figure. Okay, draw a little picture of yourself over here on the right. And remember, that's our secret. You're not supposed to tell anyone. So next here, next to these properties, I would like you to draw a stick figure of yourself. Alrighty, last but not least, we have another proof. So we're going to prove that these triangles are congruent. So it is given to us that FH here is congruent to JH, that FG is congruent to JG, that angle FHG, this one, is congruent to this one, and that these two angles. So everything that was given was also marked on the picture. Sometimes that's not always going to happen. They may give it to you and not mark it on the picture. So remember, your very first thing that you do is A, you're going to read it. Second, you're always going to mark the picture if it is not marked. Because remember, visually then it's easier to see than if it's not marked and it's just in words and letters. All right, so the plan for the proof is to use the reflexive property to show, well, in the reflexive property, something is congruent to itself. In triangles, when you have two triangles that are touching like this, basically what you have is a side that overlaps. Well, in this triangle, this is side GH. In this triangle, this is side GH. So, isn't GH congruent to GH? Yes. So anytime you come across two triangles that are butted up next to each other like this, where they're sharing a side, this is going to be the reflexive property, because anything is congruent to itself. So you can mark that. And remember, you can't just mark things like out of the blue, but now you can mark it because you know this property. We're also going to use the third angle theorem to show that angle F here is congruent to angle J. We have briefly talked about the third angle theorem previously. The third angle theorem, all that says is that if two angles of a triangle are congruent, then the third pair of angles are also congruent. Then the third pair are congruent. And if you think about that mathematically, if you subtract everything from 180 and say we're looking at this triangle over here and we have a total of 180 degrees for the angles, and you subtract out H and you subtract out G, it's going to give you this measurement. Well, you have the same measurements over here. So always, it's just kind of by default that F, that third angle, it's not marked, but since you have the other two, then you can say that F is congruent to G. All right. Number 1, FH is congruent to JH and FG is congruent to JG. That was given. Next, they want us to write the statement, and they're telling us to use the reflexive property. Well, the reflexive property is when triangles are overlapping. So we're going to say that GH is congruent to GH. These angles being congruent, that was given. The third angles theorem, like we just said, we already have two angles that are congruent in this triangle, so the other ones that are congruent is angle F is congruent to angle J. The way you know that triangles are congruent is because everything is congruent. All three angles are congruent, and all three sides are congruent. And some of these reasons may seem like common sense, but the reason that these are congruent is because of the definition of congruent triangles. Because the definition of congruent triangles is that all the sides and all the angles are congruent. Well, we have that, so we can say that the triangles are congruent. Good job, way to go. Thank you.